All right, get this, listeners. What if we told you that AI could get smarter, not by getting bigger, but by changing how it thinks during a test?
Yeah, it's a wild idea, right?
Yeah.
We call it test time scaling. And it's kind of blowing everyone's minds right now. Instead of just focusing on how much an AI knows, we're looking at how to maximize its reasoning ability during the actual evaluation.
So instead of cramming more information into an AI, we're figuring out how to make it a better test taker. That's a pretty neat trick. But how does that even work?
Well, there are two main ways to go about it. We call them sequential scaling and parallel scaling.
Sequential and parallel. Those sound familiar. Remind me.
So imagine tackling a tough math problem, right?
Oh.
With sequential scaling, it's like you're solving it step by step. Each calculation builds on the last, leading to a really focused thought process.
Okay, I can see that. So it's all about a very careful chain of thought, like a logic puzzle, where each piece leads to the next.
Exactly. Now, imagine trying different approaches to the same problem at the same time, kind of like brainstorming with a group. That's what we call parallel scaling. It's about exploring multiple possibilities and then picking the solution that seems the best. Techniques like majority voting fall into this category.
Gotcha. So sequential is laser focus and parallel is casting a wide net.
Cool. Yeah, you got it. And within these approaches, researchers are constantly coming up with new and innovative techniques. One that's showing a lot of promise is called budget forcing.
Budget forcing.
Hey.
Okay, I'm intrigued. Does that mean we're giving the AI limited resources to think with?
It's kind of like that. Think of it this way. You're basically telling the AI, hey, I want you to think about this for a certain amount of time before you give me the answer.
I like that. It's like setting a timer for a brainstorming session. But how do you actually make an AI think for a specific amount of time?
Well, it's all about how we structure the input that we feed the AI. Researchers have figured out how to use specific tokens or phrases to guide the AI's thinking process.
So it's kind of like giving the AI a set of instructions, like, think about this for X number of steps and then give me your answer.
Exactly. It's about encouraging the AI to reason more deeply before it jumps to an answer. And to really put this to the test, researchers created a special model and data set. They call the model S132B and the data set S1K.
S1K. I'm already liking the name, but what makes this data set so special? Is it massive?
Actually, no. That's the interesting part. While many AI datasets have millions, even billions of data points, S1K only has 1,000 problems.
1,000? That seems pretty small, right?
It is. But they focused on quality over quantity. Each problem was carefully selected, designed to be truly challenging and diverse.
So it's not about overwhelming the AI with information, but giving it the right kind of information to chew on.
Exactly. They wanted to see if a smaller, more curated data set could lead to better reasoning, especially when combined with techniques like budget forcing.
Okay, so we have a small but mighty data set and this budget forcing technique. Did it work? What were the results?
Well, this is where things get pretty exciting. When they put it to the test, S132B, using budget forcing, actually performed better than some much larger and more complex AI models on standardized math and science tests.
Hold on, are you saying a smaller AI actually outperformed larger ones? That's incredible. But what kind of problems were in this S1K dataset that made it so successful?
We're talking seriously tough problems here. They even pulled questions from the Stanford Statistics Department's PhD qualifying exams, stuff that would make most people's brains melt.
Oh, wow. So they really threw the AI into the deep end, and it swam. Amazing.
It did. And they observed something else that was fascinating. Sometimes when they forced the AI to think longer, it would actually go back and fix its own mistakes.
Wait, so it's like the AI was double-checking its work. That's pretty impressive.
It is. It seems that pushing the AI to spend more time on a problem led to some serious improvements in its problem-solving skills. It's like you need that extra time to really dig deep and analyze the problem from all angles.
This is blowing my mind. So, does this mean AI can just keep thinking forever and eventually solve any problem? Is there a limit to how much it can improve?
That's a great question, and it gets at the heart of this research. Let's dig into those limitations and how researchers are working to overcome them after a quick break. It's a good question. AI isn't magic, at least not yet. Even with cool techniques like budget forcing, we do run into some limitations. One big one is this thing called context window. It's basically the AI's working memory.
So it's like our own short-term memory. There's only so much an AI can hold in its mind at once.
Yeah, exactly. If the problem needs more steps than the AI can handle at once, it gets stuck. Plus, there's always that risk of the AI getting caught in a loop, repeating the same steps over and over without getting anywhere.
Kind of like when you overthink something and just end up more confused. I've been there for sure.
You got it.
Yeah.
And that's why researchers are now looking into these hybrid approaches, combining the strengths of sequential and parallel scaling. It's like giving the AI a whole toolbox of thinking strategies.
So instead of just one way of thinking, the AI can switch tactics depending on the problem. Can you give me an example of that?
Sure. Remember majority voting, that parallel technique we talked about. Let's say our AI is working on a problem sequentially, but it's just hitting a wall. A hybrid approach could let it pause, consult a bunch of other models, and use their votes to get back on track.
So it's like a team of AI experts offering their opinions. I like it.
And does this hybrid approach help with the memory problem too?
You're thinking along the right lines. Another cool hybrid technique is tree search. Imagine the AI exploring multiple paths at the same time, like branches on a decision tree.
I see. So instead of getting stuck going down one path, it can branch out and maybe find a better solution. It's kind of like those old choose-your-own-adventure books.
Love that analogy. And what's really cool is that these hybrid approaches aren't just about accuracy, they're also making AI more transparent.
You mean being able to understand why the AI came to a specific answer? Because that black box thing with AI can be a little scary, right? Absolutely. If we're going to trust AI with bigger and more complex things, we need to be able to understand its reasoning. These hybrid approaches are helping us peek inside that decision-making process, making it less mysterious.
That makes sense. Okay, but let's go back to budget forcing for a minute. You mentioned these special tokens that guide the AI's thinking. What do those look like?
Well, imagine splitting the input we give the AI into a thinking stage and an answering stage. We use these special tokens to mark the transition between the two. For instance, we might use a token like imStartThink to signal the start of the thinking process.
So it's like a little flag telling the AI, all right, time to start thinking.
Exactly. Then a token like insertAnswer might tell it it's time to actually give the answer. And by changing the number of thinking tokens, researchers can control how long the AI spends thinking before answering.
Wow, it's amazing how they're creating a whole language for the AI to understand these different reasoning stages. But even with all of that, we're still bumping up against the limits of the AI's memory, right?
Yeah, that's a big challenge. That's another reason why these hybrid approaches are so important. Things like tree search are really good at handling limited context windows because instead of just processing everything in a straight line, they let the AI explore multiple paths at once. Makes the most of its memory.
It's like the AI has to be strategic about how it thinks. Makes you wonder, if AI can improve just by thinking longer, what does that even tell us about intelligence itself?
That's the million-dollar question, isn't it? What does it really mean to understand something?
Yeah, I mean, is it just about number crunching and getting the right answer, or is there something more to it?
Exactly. Is it about making connections, drawing conclusions, having some level of awareness? And if we can teach an AI to do those things, what makes its intelligence different from ours?
Wow, getting philosophical now. But
Yeah.
That's what I love about these deep dives. We're not just looking at tech, we're talking about what it means to be intelligent.
And while we don't have all the answers yet, this research on test time scaling is giving us a glimpse of what's possible. The fact that AI can actually benefit from being forced to think longer suggests there's more to intelligence than just speed.
Like there's an art to thinking, a process of really exploring and refining our understanding over time. And maybe we're starting to tap into that with AI.
Now, to really see how researchers tackle these big questions about intelligence, let's dive into the S1 project and that S1K dataset. That 1,000 problem set has a lot more to tell us.
All right, so we've covered the why, but now I want to know the how. How did they pick those 1,000 questions for S1K? They didn't just Google hard brain teasers, right?
But definitely not. Putting together S1K was a huge undertaking. Imagine this massive library of problems, almost 60,000 of them. They got them from all over the place, math websites, physics and chemistry Olympiads, even computer science problems. That was their starting point.
Wow, okay, so they had a ton to work with. But how did they narrow it down to 1,000? That's like finding a needle in a haystack.
Yeah, it was a whole process, a multi-step thing. And they actually used AI to help. They got this Google Gemini Flash Thinking API, basically another AI, to generate solutions and these things called reasoning traces for each problem.
Hold on, so they used AI to help train AI. That's wild. What's a reasoning trace?
So it's like a step-by-step map of how the AI solved the problem. Think of it as the AI showing its work. And by looking at these traces, researchers could see how complex each problem was and how good the solution was.
Oh, I see. So the longer and more complicated the reasoning trace, the tougher the problem.
Exactly. First, they tossed out any problems that were too easy for AI to solve. No point in including those if they wanted to push the boundaries. Then they focused on two main things: the length of that reasoning trace and making sure there was a good variety of problem types.
So a good mix of really hard problems from different fields.
They got it. They wanted to make sure S1K was a well-rounded training ground. Push the AI to think hard and think broadly. And to prove that their selection process really mattered, they ran some tests.
Tests. Did they make the AI play Jeopardy or something?
Not quite. They trained different models on different parts of the data. Like one model only got easy problems, another only got math problems, and so on.
So it's like they were giving some AIs specialized education, but without a good foundation.
Exactly. And guess what? Those AIs did way worse than the one that trained on the full, diverse S1K dataset. It really showed how important that careful selection process was.
It's like they came up with the perfect AI training recipe. A little bit of difficulty, a dash of diversity, and a whole lot of quality ingredients.
I like that. But even with all this progress, that big question still hangs out there. Can AI really understand a problem the way a human does?
Yeah, that's the question, isn't it? I mean, is it just a really fancy form of pattern recognition? Or is there actual understanding going on in there?
That's the debate. Some experts think it's all about information processing. If the AI gets the right answer, who cares how it got there?
So it's all about results, not the journey.
Right. But plenty of others think true understanding needs more than that. Things like awareness, connecting ideas in a meaningful way, maybe even consciousness.
Oh, okay, now we're getting deep.
We are, and honestly, we're still figuring out how our own brains work. So replicating that in AI is a whole other challenge. But this kind of research, this test time scaling stuff, it's helping us ask the right questions.
It's making us think about what thinking even means in a whole new way for both AI and for us.
Exactly. Maybe it's not just about being fast or efficient, but about reflecting, trying different approaches, and refining our understanding as we go.
So by forcing AI to think more, we're actually learning more about intelligence itself.
That's the amazing thing about this research. We're not just building better machines, we're learning about the essence of intelligence.
This has been an incredible deep dive. We've gone from the nitty-gritty details of budget forcing all the way to thinking about consciousness.
And it's clear that this is just the beginning. AI is changing so fast, who knows what's next?
One thing's for sure, the future of AI is going to be fascinating and maybe a little bit scary and full of surprises. And it's going to make us keep asking those big questions about what it means to think, to learn, to be intelligent.
Absolutely. So to everyone listening, keep learning, keep asking those tough questions, and stay curious. The world of AI is changing everything, and we're all part of it.
And until next time, keep on diving deep.